Hi, my name is Steve Buonicontri, and I work for SOA Consulting Services. And this presentation is on Angular 4, and we're going to call it Angular because this is the new generation of Angular framework. The old version was AngularJS. We're calling this Angular. From Angular 4 on up, we'll be referring to the framework as Angular. This is an introduction. So we'll be going through a very high-level view of what Angular is and how to use some of its features. Okay, Angular is an open-source JavaScript framework used to build client applications using HTML and either JavaScript or TypeScript that gets compiled into JavaScript. We like TypeScript. TypeScript gives us all the types and the strong typing that you need for an object-oriented language. This whole presentation and all the training associated with it will be using TypeScript. Okay, the framework building blocks consist of the following. First of all, there's the concept of modules. Modules allow you to build a self-contained JavaScript file containing resources that can be shared with other modules and components, and some resources which are private to that module. So all applications use a root app module, and we include modules that we might need, like a forms module or a customer module, which might be a featured module. Loosely speaking, modules are used very heavily in Angular, and they well-defined scope within your applications and give you what you need as far as scoping of variables and stuff to really build a large-scale portal. And if you want to think at a really high level too, I kind of think of a root application module in a portal having different site areas. I'm going to try to make those different site areas different portals. Like suppose I go to a shipping page, I get a shipping module. I go to a shopping cart, I might have a shopping cart module. So you think coarse grain when you think of modules, but you're going to be using modules a lot. Okay, the concept of a component is really a component template. It's the backend class which keeps the data, and the associated template which the user which is really just the markup fragment for the HTML, which binds the data from the which binds the data from the component to the template using different directives. So there's the concept of data binding, and the metadata, which is really represented as annotations, really say, oh, this component manages this template, and this component has a style sheet in this directory, and the metadata basically tells Angular what to do and how to do it based on this annotation-driven language. We have the concept of data binding, which is extremely important in Angular. Yes, if you change a data attribute in a component, it could be bound to the template, and you'll see a different visual representation in the template, and vice versa. If you click on a button in the template, you can invoke a method in the backend object, so the event could be binded to the backend object. And so there's the data binding is extremely important. Angular 4 supports a one-way binding, and what that means is one way from template to backend object, or from backend object to front-end template. And if you want a two-way binding, you could use a different syntax to have both directions. Services are extremely important. You build reusable services. You define them as a provider. You inject them into constructors if that component says, declares that the component or the module declares that service as a provider, you get the service automatically dependently injected into the component using dependency injection. And of course, there's directives there, which are things you use in the template to say, when the user types this in this field, I want you to bind that to data in the component and then call a web service to give me some result. etc. So there's these directives which also have metadata associated with them, which tell Angular how you want the component template to behave based on the template directive. And of course, dependency injection is a very sophisticated pattern, and we basically use that quite a bit. Mostly, I define services and inject them into components so the components can access the services. Okay, here's the big picture everyone's been showing. I pretty much really put a little bit of detail in here for our benefit, but the bottom line is TypeScript is a superset of ES6, which is a superset of ES5, and all the browsers have different functionality levels of ES6. So and TypeScript transpiles into ES6 or ES5 at the moment. So we have to look at this and say, what do we really want? And the big picture here is this: you want TypeScript that has all the high functionality that you need to make sure that whatever you're coding is going to work properly. But let's go through some of these really quickly. ES6, when you look at it, you get excited. There's a lot of things that are going to really help you with functional programming and object-oriented programming. And when you see them, you say, oh, I could use that, because I know I struggled with a lot of these, implementing a lot of things in JavaScript, and all of these features in ES6 help you. You've got temporal literals. Temporal literals are literals which allow you to use this $paren syntax to bind some data attributes in your component to your strings, let's say in your template. So useful, and it's the way of saying here's a string in a template, and here's some dynamic data that's getting wired to it from the component. We have the concept of multi-line strings. There's a backtick syntax you could use right now and put your markup fragment in multi-line, so you could see your HTML in your component, in your template, in your component, wherever you want to put it. You have the concept of block scopes. Loosely speaking, ES6 fixes a lot of hoisting issues, and there's the concept of block scopes. You could put a left paren, right paren, put a function in there, and that function has that block scope. Arrow expressions are beautiful. You basically define an argument, a fat right arrow, and a function definition. The syntax is very simple in a lot of different scenarios, and we'll see a lot of that. Some people might think of these as lambda functions in Java 8, or to me, it's just a simple way of building functions and using them in line that are very, very helpful. We've got the concept of rest and spread operators. If you have a function which has a dot variable name, function definition, you could basically, from a client, call that function using 3, 5, 10 arguments, and those arguments would wind up going into that collection, and inside that function definition, you could pretty much use this collection syntax to iterate through the objects. And spread is the same thing. You can have a collection and pass it to a function that has an argument list, and you could spread a collection across the argument list. So those are very useful. And then there's the concept of generators. Generators allow you to invoke a function and yield. And so you could do next, and iterate the first part of the function, the second part of the function, the third part of the function. And those are very useful. And there's the concept of destructing objects, destructing arrays. Bottom line is, if you have an array or an object, and you say let left paren, attribute 1, attribute 2, attribute 3 is equal to some object or some array, the destructuring of the object or array would wind up filling those variables. And I think that's a really nice thing. Usually you have an object with 2 or 3 attributes. You just want the attributes. You don't want to write the code to go get the attributes. So you just declare the attributes and destruct the arrays. For each, for in, for ofs, you have these capability of iterating through these objects in different ways. Take a look at that. And of course you have classes, inheritance, constructors, static variables. You have a super keyword, super function. So that gives you your object-oriented capability, your way to reuse existing classes, define constructors. So in Angular, you're constructing an object. You could be initializing it. You could be at all different phases of the life cycle object. You're defining state, whatever. So these are very important things. And of course, you've got promises, and promises, I'm going to say, are very promising in ES6. They're very clean, and the bottom line is, most of you know from client code, if you call one web service, you get a result, and you want to call another web service based on that result from the client end. It's not as convenient as with Node.js, where you have the async module, but the promises help with that, and looks a lot cleaner. And of course, you got the concept of modules in ES6. Okay, moving over to TypeScript, you say, well, wait a minute, looks like I'm listing the same types of things, but the bottom line is TypeScript gives you strong data types, function argument types, function return types, default parameters, optional parameters, arrow function expressions, with stronger typing, and class access modifiers. There's a lot of things that happen within TypeScript which don't happen by default in ES6, and you'll find out some of those things. But loosely speaking, more simplification, stronger typing gives Angular the ability to do a lot more things. And then of course you got generics, interfaces, and you got callable interfaces, and you've got annotations. And annotations is what really helps Angular do what it needs to do. Let's move on. What is an application? Very simple application. It's a web page, and you introduce an app module using a custom app directive which defines a component template that's going to be rendered in the page. So it's an HTML page which fires up a JavaScript application, and then as soon as the user starts interacting with the markup fragment or the view inside the Angular constraints, Angular takes over and starts doing things for the user. By the component managing the template, and Angular managing everything associated with the event handling, etc. That's basically the simplest form of an application I could think of. So basically, you've got this root module, which is an app module. All Angular apps have a root module, and that app module typically has a root component, and that root component has metadata associated. That root component is the backing object, which does a little work. And the metadata says, oh, we have a template associated with it, and that template has directives in it, and basically, as the user is interacting with the template in the front end, data is getting in the components changing, etc., etc. So this is the simplest form of the application. And the power comes in with the event handling and the property binding. When data is initialized in the component, let's suppose the component gets constructed and it calls a web service and data state changes, that data attribute could be bound to the markup fragment. So there's property binding, and then if the user clicks on the front end, a function could be invoked in the back end component, and that's called event handling. So this is what you're thinking of as you're modeling your component. You're mapping your template to your component. You're trying to define how the application is going to behave, and you're using directives to define event handling and property binding and everything else like that. Okay, and just a little bit more about the template. The directive in a template tells Angular how to transfer the DOM. So if you're looping through a data and you're saying, well, if this user attribute has the value true, include the row of the table, else do not. Basically, you're transforming the DOM. And so as you know, the power of Angular comes from transferring the DOM, because the browser is waiting for DOM changes, and when DOM changes, the front end changes. So Angular is really taking advantage of what the browser is going to do by default. And now the important thing is here, right, is any application is going to use services when you start building applications which are real. You have this concept of an injector, and you can inject a service into a component. So the component has a constructor, and the constructor is where you inject the service. And if the component is up, alive, and ready to function, you have a handle on that service. So when you do the event handling and you invoke a function on the component, that function definition can actually invoke a function on the service. And services have multiple forms. You've got custom services that you can build, which I call service, and there's built-in services by Angular, which are called HTTP. HTTP is a very, very common service which Angular provides, which you're always calling. It returns an observable, and you usually do gets and post against this HTTP object. And so when you construct an application and you use services as well as dependency injection, you basically say, well, I'm going to inject my HTTP service into my custom application service. And then I inject my custom application service into my application component. So the bottom line is Angular does all this for you automatically. The services are considered, you declare them as providers, and once you do that, you could inject them into your components. An Angular application uses modules, and modules are very, very important, because whenever you need a feature, you might need to include a module. So the common one, the common one is core. You always use core. Core has everything you need when you declare a component, and so, or modules, and you're always importing the core module in your app module. But an app module does use modules. They're shared modules like core, common, forms, router, and there's featured modules. Like I create a customer module which has all the resources I need to handle my customers. And what does a module contain? A module contains components, directives, services, values, functions, and a module metadata has certain properties. You declare components, directives, and pipes that you might need in your app module. You have exports. You make declarations that can be used outside of the module. I don't typically do that when I'm building a custom app module, which is using all these things. So, but that's what an export's used for. Imports. Other modules whose exported component and templates are needed by the class. So if I'm using forms, I need to import the forms module. If I'm using routers, I need to import the router module. And like I said, when I'm building site areas, I build custom featured modules. I'm going to build a customer module and a shipping module and a shopping cart module, and etc. And then it's the providers. Providers are creators of services that this module contributes to the global collection of services accessible to all parts of the app. So providers are the services I'm using. Let's keep it simple. Bootstrap, the main app view called root component. So my app module will bootstrap a root component. In this case, in this example, in this picture, I have one component. I need to bootstrap it for the application. And a word about a simple application and the different resources that might be involved. You do have an index.html. You do put a root app directive in the HTML page to say, hey, I got a custom app directive. I'm going to use Angular to implement this. Now, the index.html, and the index.html, basically what it does is it uses a loader to load a main app. Let's call it main.ts. And that thing bootstraps an app module.ts, which is my app module. The app module defines app components it's using, etc. So there's different system loaders. System.js is one of the more popular ones, but using Angular 4, I at the moment it doesn't really matter what I'm using right now. I'm using Webpack. Angular CLI is doing a lot of stuff for me, and you have the option of transpiling your TypeScript code in your development environment or doing it before your code gets loaded into the browser. So these system loaders do things for you. System.js is one of the better ones, and I did all my Angular 2 using System.js. But I just wanted to paint the picture of a scenario here which simplifies a Hello World application. The loader is important. The packaging and deployment is important, but let's focus on development. So the package.json file defines all the JavaScript modules needed for the project. And basically Angular CLI is building that for me, and I don't have to worry too much about it. I'm in WebStorm. I used Angular CLI to build an Angular 4 application, and it generates these files for me. If I update my modules in my using the Node package manager, I do a -- save to make sure that the package.json file is updated. And the tsconfig file declares a folder as a TypeScript project. It defines TypeScript files and compiler options. Okay, so just to give you a little idea, when you start an Angular 4 project, do a node-v, make sure you're using a good version of Node, a more recent version of Node. You need TypeScript 2.2, and I'm converting over from Angular 2 to Angular 4, and the bottom line is upgrade everything. I upgraded my WebStorm development environment because by default it wasn't supporting TypeScript 2.2. So I upgraded my WebStorm environment. Prior to that, I upgraded my Node version. So I'm starting with the latest, greatest of things, and the bottom line is you have to make sure you have a good version of Angular CLI, which is 1.0, and then you have to make sure that when you create a project with Angular CLI that you're using Angular 4. So do a node-version, make sure it's up to date. Do an npm-v just to see what you're using. That would be a different version. The package manager and the Angular CLI will be a different version. Angular CLI version is 1 now, and they're keeping that separate from Angular 4. And when you create a new project, you do an ng new hello world, and then go into that hello world and do an ng-v, and you'll see that you're using Angular 4. But when you create the new project using Angular CLI, it's going to create a lot of things for you, and just use whatever it gives you. Okay, so like I said, with Angular 2, I did a lot of custom stuff. With Angular CLI, with WebStorm, I create a new project. I use Angular CLI project, and it's generating a lot of things for me. Now it's using Webpack. Webpack is using some loaders, Angular CLI and Webpack, whatever it's doing behind the scenes, it's working. It's not working as good as my Angular 2 projects. Things are a little bit slower, but it's doing a lot more work. It's making the application smaller. So there's a lot of things happening behind the scene. Just bear with it. And if you look at the modules that Node.js has in your package.json file, it's going to load all the things that you might need. The common, the compiler, the core, everything that you might need here. Okay, so let's go through the packages. TypeScript.js adds optional types, classes, and modules to JavaScript. TypeScript supports tools for large-scale JavaScript applications for any browser, for any host, for any OS. TypeScript compiles to readable, standards-based JavaScript. We call it transpiling. Core.js is a modular standard library for JavaScript. It includes polyfills for ES6. Angular CLI now with Angular 4 comes with something called polyfills I'm using. So let's just focus on the polyfills. Angular CLI is making sure it's used by default. I'm not worrying about it. RxJS is a very, very important reactive extension. It's a reactive extensions for JavaScript. It's a set of libraries for composing asynchronous and event-based programs using observables, sequences, and fluent query operators. It's the observables you're using. You call a web service, you get an observable as a result. You subscribe to it, you get streamed the data. So that's the important thing. Using RxJS, developers represent asynchronous data streams with observables, query asynchronous data streams using many operators, and parameterize the concurrency in the asynchronous data streams using schedules. Okay, let's just simplify this. When you get a stream, you get a stream of data. You could map it. If you map it to transform it, do whatever you want to get what you need. It's very simple. Zone.js is a zone. It provides all of the change detection mechanism used by Angular. If you have Angular application is a component tree. If you change data in an attribute, in a component, in a leaf of the tree, Zone.js is going to be used to look at that change detection to determine what to do with your Angular app. So you don't really have to know too much about it. It's being used and everything's being done for you automatically. System.js is a configurable module loader that can import modules at runtime in any popular formats used today. Common.js, the universal module definition, the AMD, the ES6. It's built on top of the ES6 module loader polyfill and is smart enough to detect the format being used to handle it appropriately. System.js can also transpile ES6 code using languages like TypeScript. The packages which we're using are Angular Core, Common, Compile, Platform Browser Dynamic, Forms, HTTP, and Router. And you'll know when you need to import them because you know when you're using Forms, you know when you're using a router, you know when you're calling an HTTP service. So, but there's some that you always need. Okay, so let's just go through them really quickly. Angular Core provides the basic functionality needed for decorators, zones, dependency injection, internationalization, language, animation, reflection, metadata, linking, facades. And by the way, there's something wrong with this slide. Animation has been pulled out of the core package with Angular 4. So I will change this view graph. Angular Common provides support for directives, pipes, locations, facades. And if you really want to know what's in these things, either just go into your nodes module and look at them to determine what's in there. The compiler does ahead of time compilation, just-in-time compilation, expression parsing, template parsing. And then you got platform browser. That introduces all your browser functionality, your rendering, your DOM events manager, adopters, location history, sanitizing, security, window, collections, etc. You're building browser applications, you're going to need platform browser. Platform browser dynamic introduces the dynamic browser functionality, the resource loader, the platform providers, imports, exports, lang, etc. And of course, then you get into you can call these feature modules forms. When you need forms, use the forms. Support for template-driven or reactive forms. There are two types of forms in Angular. One of them is template-driven, the other one's reactive. And we'll go over that in great detail. In template-driven forms, you have directives, which map your data in your template to a JSON object and passes it to your backend, your backing object. Reactive forms are a little bit different. You design a form in your class, and then you construct a template to map to the reactive form, and you get all of these reactive features that are very interactive functionality that are really, really useful. So the complex forms will be built with reactive forms. The simple template forms will be template-driven forms. Then you got Angular HTTP, provides methods to perform HTTP requests using the HTTP object. When HTTP is called, it returns an observable that emits a single response when a response is received. That's what we're trying to say here is, you have an HTTP object, you do a get on it. Until a code subscribes, the web service will not be called. So when you subscribe, the web service is called, you get streamed the data. And a router, support for routing, routes, router outlets, router links, and we'll see a lot of that. Okay, so basic application, you got an index.html, you introduce a custom app tag. And then what you do is you have an application component, let's say it's green, and that application component has an app tag, has a navigation tag, a product list tag, and a footer tag in its template. So you're talking an Angular application with a backing application component. You got an application module, you have a root application component, which is green, and then you have a child component. Inside your application component template, you have a product list template. That product list template has a backing object called a component called product list. We have a product list component template. That particular child object has a service injected into it at constructed time, and that product list object calls, let's say it calls a web service, gets results and renders the product list in the application, in its template. So we're going to go through some examples, introduction. One of them is a seed. Angular CLI automatically generates a seed application. We'll go through that in detail. Then we'll look at a starting application, hello world application. Start using some different features. And we'll look at a basic application which tries to use a lot of the features of Angular, the coarse-grained features. And we'll look at pipes. There's directives, there's pipes, there's components. So we'll try to describe a lot of these things as we go through our example. And that's, stay tuned for the next video, which will go through all of these examples in detail.